talking back there? We're in this meeting now. We're in this presentation. You guys are in the right place. Talking about everyone's favorite topic. Let's hear it. Yes? Open source risk. Yay. Yeah. Hey, you guys are here. You're missing lunch. I appreciate that. Some of you guys are eating. That's OK. I'm not staring at you chewing or anything. You're here. You're here because I also care just as much as you do, hopefully, about open source risk, how we can actually get better at this. How do we actually mitigate and prioritize risk in our open source, in our supply chain? And I'll tell you a little bit about what we're trying to do right now. We're using CVSS, right? CVSS. I'm telling you, it's a broken system. I'm going to show you some better ways. Well, hopefully. That's why you're here, right? Naomi, that's why we're here. We're missing lunch for this. So let's talk about open source risk. But first, about me. My name's Naomi. This is what I look like. I'm the director of product security at Contrast Security, where our mission is to get secure code moving. Hi, welcome. You're not late. Come in. It's all good. I'm going to not make you feel awkward at all. My Twitter handler is there. Congratulations to Elon for purchasing us. Some of my hobbies are up there too. Parenting, if one calls parenting a hobby. Volleyball and volunteering through my nonprofit. I have one called Cybersecurity Gatebreakers. And we're here to break down the gates in cybersecurity. All right, that's about me. But you didn't come here to hear me talk about me. All right. Let's talk about how we build software today. And you guys are all smart. I'm not going to tell you something you don't already know. But these slides are fun because I put animations on them. So let's see. This is what our software factory looks like today, right? Your dev shops, your engineering stores, all your teams here. This is how we're creating software today, or is it? Now, when our developers are writing code, they're going to be introducing vulnerabilities. That's just how it is. This is their custom code. We're not even talking about open source yet. Just the custom code that they write inherently will have vulnerabilities. Even if you're the best developer in the world, I'm sure you guys are all amazing engineers, you're still going to have some vulnerabilities. And this is what a traditional vulnerability attack vector is going to look like. You're going to have traditional attackers, cybersecurity threats, and malicious actors. But this is why there's a big white space over here. Today, our software factories include other things like dev tools, build tools, dependency tools. And we have different things like open source, I need some lunch too, guys. Open source libraries. And we also have the attack vectors that are not as traditional. We have attacks on software, on the software factory itself, as well as attacks on the software supply chain. So if you're thinking about this, think about some of those previous examples, which I took studious notes on. Who can tell me a very famous supply chain attack that happened very recently? SolarWinds, thank you. That was the only one I had actually in my example. Perfect. It's a plant. Kaseya was a good one too, ransomware. Yep. So what happened with SolarWinds Orion? Anybody know? What part of the supply chain here, the factory, was compromised? Build system, yes. This guy's smart.
I learned that yesterday.
Oh, you he says he learned it yesterday. So, and what? Orion was servicing, what, hundreds of clients, if not thousands, and it wrecked a lot of us. I don't know if you were affected. Don't want to call that out. But we want to be on top of these things. SolarWinds was really bad. Things like dependency confusion. If you heard of this one, this one's really interesting. Who knows about dependency confusion? Yes? Yes? Oh, awesome. Adam. So the idea here is your package managers will check public repositories before they check private ones in some cases. So one guy decided, I'm going to check something. He's going to make package names guessing the internal package names of companies like Apple, Microsoft, PayPal. And he actually guessed right. He actually was able to inject his own packages using this dependency confusion thing, another part of the supply chain. So things that you probably didn't even concern yourself with, they're all built in because all these vulnerabilities are built in because of how software is written today. And if you think about it, the more you adopt open source, the higher your risk is going to be. And I'm going to spend the next 20 or 30 minutes with you describing why that is, if you don't believe me already. Again, you're all smart. I'm not going to tell you something you don't already know. I'm not going to read this whole thing. But just that bold one, I want to call this out. Vulnerabilities in open source code increased 50% just last year. And who can tell me the number of CVEs that are actually published or sent to the public CVE places every day? Who can tell me that? Just guess. Less than 10?
15.
Ooh, close, not that close. What?
9,000.
No. Sorry. It's actually less than 100, but still pretty high, 70 something. On average, every day, new CVs are published to MITRE, to all those different places, the repositories there. It's a lot. And so as we are adopting open source, you could see a 50% annual increase for companies using open source. So even this pandemic has accelerated something like digital transformation, is like the fancy term for it. People are actually doing more of this building using open source for their companies. Makes sense. An average of 118 libraries for open source libraries found in applications. And here, focus on this one, this bold one. The likelihood of a serious vulnerability in a library increases 6.2 times as the library ages from 1 to 4 years old, which is very important because, who wants to guess, what's the average time it takes for a vulnerability to be published or found in open source? Who wants to guess? Audience participation, check. 1 year? No, 8 months? 18 months. Oh, no, that's the breach. That's how long it takes to discover a breach. We all have jobs forever, guys. We're not going anywhere. So, no, it takes 4 years. GitHub, John, GitHub. You guys did a study, awesome study that said, like, on average, it takes 4 years for a vulnerability to be found in open source, which is crazy if you think about it. So in those 4 years, that vulnerability has been sitting there. Who can tell me how old Log4j, that vulnerability, how old was that before it was discovered? You can give me the year. I had to look this up. It's not like I knew this. Close. It was actually 2013. So it was almost like 8, 9 years before it was actually, someone knew about it. And then it blew up, right? So, but what are some of these ways that we can actually get better at that? That's what this talks about. And then take a look at this highlighted one here. Once CVEs are trending, people start talking about it on Twitter. Again, thank you, Elon. Once people are talking about CVEs, the bad actors are going to try to exploit them just because they're trending. But here's another interesting statistic. What percentage of vulnerabilities have exploit code written for it of all time? Who wants to guess? What percentage of CVEs? Yeah, 1%, 2%. Crazy, right? 2% of all CVEs of all time have exploit code written in it. So what are we doing to our poor developers today as security people? Do we not walk up to them with a list of CVEs and vulnerable libraries and be like, here, patch this? Like, they hate that. Who's a developer here? See, he hates me, right? Be like, here's some vulnerabilities. Go ahead and fix that. What's taking you so long? And then and even worse, we use CVSS to be like, it's a critical, right? The 10.0. Okay, who can tell me what the average CVSS score is? Who can tell me? What do you think it is? 2. This guy. You win. I don't have anything to give you, but you win. 7.2 average CVSS score. And it's a little bit skewed because if you are a researcher and you're trying to publish a CVE, you're going to want to tell everyone it's critical just to get the clout, right? So it already kind of skews high. So we don't really need to use CVSS to say how high or critical something is because we're not contextualizing that score. We're just saying, here's a vulnerable library, here's a CVE, go ahead and patch this. It's a CVSS 9.8. And then the poor developers are going to be like, we don't even use this library, right? Right? That's why he hates us. So is there a better way of doing this? Yes, there is. And you are missing lunch to hear this solution. So the folks at Contrast, we created a state of open source security report. You can go out there, contrastsecurity.com. We got a copy of it. Nice PDF, really long, great reading for your children. You're going to go out there and look at it. You're going to see we came up with a little bit of a framework to understand how to actually measure risk in open source. So instead of just giving somebody a CVSS score and just say, have fun, Merry Christmas, right? We are actually going to show them a better way. We're going to tell them contextually how this affects our organization, how this affects our application, how this risk, and again, all security is managing risk, how we are going to help manage and mitigate risk for those applications. So we have 5 layers. Everything's a layer in security. Risk layer, what? We need better names for these things, right? But anyway, we got 1, 2, 3, 4, 5. And I'm going to go through each one of these, so I won't read them straight out to you. But the takeaway here is there's a better way of doing risk prioritization. The one that we talk about the most, who can point it out to me? Out of 1, 2, 3, 4, 5, who can tell me which one it is? It is 4. The one we currently use, vulnerabilities and libraries, that's what we're currently using to show our developers that, hey, you need to fix this. We're using CVSS scores. We're handing over names of vulnerable libraries, and we're saying, patch this. It's not working, but it is one of these layers. Contextually, throughout all the layers, it's going to be better than just the one layer. All right, and here's your obligatory eye test for those of you in the back. It's OK, I can't really see it either. You taking a picture? Hey. So here it is. On the left, we got the number of libraries. On the right, we got the different frameworks and the libraries. We got Java, .NET, Node. Our state of the open source security report focuses on these 3 major languages and frameworks. And you'll notice a massive difference between the different languages and frameworks. You got Java, on average, the number of libraries per application, 17% of them use 0 to 24 libraries for that application, compared to .NET. And this is interesting. There's 1 library in 43% on average of .NET applications. Who can tell me what that library is? If you can, who's a .NET developer? Yeah?
Is it Microsoft JSON?
I'm not a .NET developer. I have no idea what, no. You could have told me anything, bro. You could have said literally, OK. So 43% of .NET, and this is because it's a closed ecosystem. Java, you just got a lot more. Java bundles everything together and be like, here's Spring, and then you're like, OK, I can build all the things. But like .NET, you really can just do basic stuff. Node here, and this is interesting. Who's ever done a Node project? Yeah? Is it not true where you want to do one thing, and then you need to like download 500 megs of dependencies, right? You're just like, this is great. My package is going to be so small. No. My binary is low. No. Sorry. So that's the idea. Like the averages over here have almost 1,000, like almost over 1,000 on average for Node applications. And that's crazy. But some of the insights there, question already, nice.
Is that including transitive dependencies?
Ooh, I'm going to get to that. No, it does not. Does not. These are just first level, first order dependencies, yes.
By all those numbers by like 10?
Yeah, he's asking about transitive dependencies or dependencies of dependencies. I'll get to that, but no, these are just those first order dependencies, direct calling libraries. All right, the insights for this. Take a look at Java, 125 libraries on average. There's a logging framework, not Log4j. This one, I don't even know what this one's called, SSLF, something other logging framework here. That's the most popular, with Spring Core a close second, and it packages all these vulnerable libraries up together. I'm going to get to the point here. But if you're packaging up all these libraries and all these dependencies, they're going to have some vulnerabilities in them, yes? Nod your head if you agree. Yes? But are you using those libraries? Are they active in your application? No. Maybe. You're killing me, bro.
Certainly not all parts.
Not all parts, right? I'm going to get to that. We have data here in our report that you guys can download, but it shows how you can use data to show your developers a better way of assessing risk for your open source. It's not just throwing those CVSS. And I'm trying to get you guys away from this. Please, 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 if you're a security person, don't just create a report and send it to the developers. They absolutely hate that. Awful stuff. .NET, on average, have less than or fewer than 14 libraries. And here's the name of the library, by the way, system.servicemodel.web. Again, you could have said anything, bro. I'd been like, yeah, that's right. Top library in 45% of applications. And in Node, 65% have 500 or more. This is crazy. Debug being most popular, and this other one I had to look up, milliseconds, converting time to milliseconds is the second one. All right. Now it's down to the good stuff. This is why you came here and paid all that money for me, right? Risk layer 1, active and inactive libraries. I mentioned this just before this. But if you have all these dependencies and all these libraries, not every single one of them is going to be active. Who can guess what percentage, on average, across all applications are actually using, like, what percentage of active libraries are actually being used? What libraries are actually being used by an average application? I could have said that way better. That's a good guess. He said 25. Anybody else? You can't go wrong. You can just literally shout out anything. It's not like I have a whip out here. 30, that's really good. But yeah, $1. It's actually 38%. I like you guys. You guys are great. 38% of all libraries are actually actively being used by an application. And here's the breakdown. That's across all the applications, thousands, tens of thousands of the ones that we analyzed across, on average, 38%, 24% of Node applications, 42 in Java, and 67 in .NET. So if you think about the inverse, like that 100% of all libraries and dependencies that are packaged in as part of your builds, only 38% on average are actually being used. That's quite low. So you're thinking, oh, so my open source risk, not that big of a deal, right, Naomi? And I'll have to tell you, no, actually, wait, hold your horses. There's still some bad things out there. I can't tell you, like you can't just ignore. Yeah, question again.
On this number, does that include also net dependencies versus production?
Actually, for our analysts, I speak two languages, it gets me confusing. Our analysis is for any app that was actually uploaded into our system, so it could contain a dev and it could contain prod. So yeah, it's just everything. Yes. So sorry. All right, but some nuances here. So if you take a look at this, 12 of the top 50 Java libraries are active in more than half. So even if only, 42% of Java applications have active libraries in it, 42% of the libraries in a Java application are active, 12 of the top 50 are in more than half. So if I were a malicious actor, which 12 would I focus on? Right? The 12 that are up in the top 50. If I want to, I would just go be like, what are the top 12 Java libraries that are being used across more than 50% of the applications? And I would look for those. I would look for the CVEs, and I'd try to write some exploit code for them. Right? Because attackers aren't stupid. And this is the reason why I want to bring this up. They're no longer going for those single attack or single target victims anymore. They're not going for your one banks or your two banks. They're going through supply chain because why? It hits so many more victims, right? Think of Kaseya. Think about Orion. You've got not just one victim, but hundreds and thousands. And why not? You spend the same amount of time trying to pop somebody, you're going to just pop everybody now. And that's what happened. They just profit. They're so much smarter. So that's what I would do if I'm a malicious actor. 49% of .NET have one active library, and in Node, top 25 libraries are present in 92% of applications. All right, most common library active in 42%. Cool. All right, so what I'm trying to say is here, we really can't rely on some of the standard tools that we use today. Who here uses software composition analysis, SCA? Okay, yep, good. It's good, but it doesn't give you the full story. What, you feed it an SBOM and it tells you all the CVEs related to the libraries that you're using, right? Like that's okay. You're still going to need some of that. But again, that's not enough. You need contextual information. But in this case, for Log4j, if you notice, we actually found that SCA tools have over-reported Log4j. So we actually had one, shall remain nameless, but our endpoint protection system actually scanned local file system for Log4j. So what was the jar name? log4j.jar, right? And it found it in like hundreds of endpoints, and it starts popping alerts. It's like, okay, yeah, we found all these, and guess what? That code is never reached. That code is never actually like used at all because it's just someone happened to download it or something, or a package manager and put it on their file system. It was never actually used for anything. So think about the false positives that came up in that alerting system. And now you got to chase down every single one. No thanks. See, that's where we all retire. We move to the Bahamas and say, you know what, I'm just going to do something else for a little bit. And Log4j happened, you know. Who was on PTO for Log4j? No? You. Christmas. It was Christmas. Yeah, you were. Oh, I'm sorry. Oh, did I bring back bad memories? I'm sorry. Oh. No correlation whatsoever. Yeah, that's Christmas ever, actually. All right. So Log4j completely overreported by standard SCA tools. So what SCA won't tell you, this is the contextual data I want to like hit home for you guys. SCA is not going to tell you if your dependencies are only used for testing. They're not going to tell you about transitive dependencies. They're not going to tell you about dependencies that are inactive or unused. Right? This is the stuff that we need to help our developers with. If we are just giving them lists of CVEs and vulnerable libraries, they don't know how to prioritize that. So why don't we help them out by giving them more information to help them be like, you know what, this one is imminently exploitable. We want to focus on this upgrade or this patch. Let's do that one first before all the others. And they're going to be like, oh my God, I love security. Right? They're going to be like, you're so helpful, finally. Log4Shell, here's some numbers for you, some interesting stats that we found. 64% of Java applications package log4j2, and the still vulnerable log4j1, but you do need the JMS appender library to go with it, so otherwise it's not exploitable. And 50% of Java applications package the vulnerable version of log4j today. So even after, yeah, Alex is laughing. It is funny. It actually is funny. Like, do you guys go on Twitter like the day after Log4Shell happens? Like, some people were on the long vacation, like the 3-day vacation, and they come back on Monday. Hey, what did I miss? You know? Like CISO, security leaders, like, what did I miss? And be like, you just lost 3 days in an incident. Like, you need to figure your F out. Like, you got to do this now. All right. So related, Spring4Shell. Who heard about Spring4Shell? You guys should know about Spring4Shell because it's actually worse than Log4Shell. Yeah, you probably didn't hear about it, right? Because everyone's freaking out about Log4Shell. Spring MVC. You would think, you're like, oh, none of my Java apps use Spring, I'm good. No, it's actually packaged in like a ton of stuff. So if you take a look, 74% of Java applications use Spring Core. You're like, oh, I don't use Spring MVC, that framework's old. 74% comes packaged with it. 71% of Spring apps on Tomcat and Java 9 have at least one unchecked auto-binding vulnerability. This is mass assignment, guys. These numbers are actually higher than Log4Shell. Look at this. You got 64 versus, what, 74. So Spring4Shell, bigger problem, big problem. 85% of Java Spring applications package a vulnerable version. So it doesn't tell you the true story. Your SCA tools can give you information. You just need to contextualize it and make it better. All right, let's head on over to risk layer 2, active and inactive library classes. So you've got your active libraries and inactive libraries. Now the classes within the libraries themselves. Oh, I was supposed to ask you to guess. It doesn't matter. 31% of classes in active libraries are actually invoked. So that means, in total, here we go. So out of all application code, overall, less than 10% is actually active library code. So that means 90% of the code that your application is running is custom code, which is where you should be focusing your attention if you are doing things like secure code review or any kind of security activities for your applications. So if you are doing the opposite, if you're doing like 90% of your time is like fixing vulnerable libraries and like 10% is doing threat modeling and like secure code review, like flip that on your head. It should be 90% of your time focused on custom code and securing that, and then like less time for vulnerable libraries. Because why? What are we trying to learn here? Open source libraries, it depends. It really just depends. So you can't just say there's a really high CVE or CVSS score. Now go ahead and fix this. Your developer's going to be, wait, what about all my custom code that I spend months writing? What about that? I'd be like, nah, you're fine. Like, you can't do that. Not going to be helpful. Some nuances here on average for the average Java app, 279 classes in a library, but only 32% of those are invoked. This is your average library for the average Java application. In .NET, 138 classes on average in your average library. Only 67% of those classes are invoked. And in Node, since Node, everything's bundled in smaller packages, 8 classes in a library, only 5% of those classes are invoked. So you really want to think about the data here, because if you are focusing on the wrong things, your developers are we're going to have a really hard time protecting your applications, right, as security people. I won't say developers, us. Some metrics here. Another eye test for you guys. Here are some the most common Java packages and libraries that are used in our applications across the world. And you'll see, on average, only 32% of those libraries are actually used. Those classes are invoked somehow, some way. So there's a ton of libraries out there that are just not active, classes that aren't being used, which is interesting, right? All right, moving on quickly to risk layer 3. Any questions so far? I think I'm losing some of you guys. The phones are coming out. That's okay. I get it. Open source risk. Really thrilling stuff, right? You guys, oh, best audience ever. Risk layer 3, library age. Now this one's important. What did I say it was? 6.2 times more vulnerable as it ages. And it takes 4 years on average to discover a vulnerability in open source. Here are some more averages for you. Java, it takes 2.9 years to find, 2.9 years an average library is how old it is in Java. .NET, 1.3. Node, on average, 2.6. And like, you think about this, like, why are our libraries so old? Like, who can give me some good reasons why a library might be outdated or 3 years old on average? No financial support for open source. I like that. I don't think open source is generally financial. Yeah, okay, I can see that. Like Log4j.
Because it's hard to, you don't have a motivation to fix anything to continue developing.
Yeah, or something new and shiny comes along and you're spending your time building that, right?
Or if Microsoft doesn't buy your company.
Yeah, Microsoft doesn't buy your company. So some things like, hey, that it's no longer being supported, right? That project is just old. Other things like, hey, maybe it got forked to a different repo and now someone's actively managing the fork instead and you're just pointing to the wrong one. Yeah, got an idea. What's that?
Or your code base is wildly complex, like OpenSSL.
Oh, okay.
And no one understands it.
No one understands it. Okay, that's fair. That's a really good point. And here's those stats again. Those libraries are old. 28% are fewer than or less than a year old, and 31% are 3+ years old. And this is our analysis. We found that very interesting. Hope you guys do too. Risk layer 4, jumping ahead. Vulnerabilities in libraries. All right. So this is critical to think about, guys. When we hand over our list to our developers and we say there's 1,000 CVEs for all these libraries in your application, we're telling them the green stuff. We're giving them the green stuff. Hey, 94% of your applications have at least one CVE. We're telling them this is it. But if you take a look at the yellow, those are only the active libraries being used. So those, like, the possibility of being exploited is that yellow. It's at 8% for Java. And look at .NET. .NET is like barely registering at 1%. And Node is 2%. On average, 6% can be exploited. Like, the active libraries can't be reached, right? Sorry, the libraries can't be reached. Active libraries, yes. 5% of active Java libraries have serious CVEs. Here's about .NET, less than 1%, and Node 2%. And the likelihood of critical CVE being present increases from 7% at 1 year old to 44%. That's a huge one. All right. So what I'm trying to say is there's a ton of false positives in open source. If you're running SCA tools, you're going to end up with a ton of false positives. And as a security professional, you are doing a huge favor to your developers if you are triaging some of that information. If you're putting contextual data around it and you're telling them, yes, this library is being actively used, this is going to be your top priority. All right, I think I've hit that to death. Other factors to consider, and here's something you guys might not have heard of because this is fairly new. Not CVSS, everyone knows about this, but EPSS. Has anyone heard of this? I think it was mentioned a couple times. Adam, you used to do my job, so that doesn't count. Let's see. All right, you guys should check this out. Actually, I'm going to do a quick demo because I think it's fun. The EPSS is Exploit Prediction Scoring System. It uses data from different sources. It's going to look for published exploits. It's going to look at the CVSS scores. It's going to look for the probability of a CVE, that exploitability of that CVE. So, like, how likely will this vulnerability be exploited? And it gives you a probability score, a p-score. And so that, if you go first.org, they're the same folks who do CVSS. They actually have an API, really nice. You can look at all the top 100 CVEs with the highest probability scores that it is going to be exploited.
Yeah, you think you're sharing that?
Whoops. I'm new to this technology stuff. Okay, how's that? Yes. Yeah, we'll be friends. So the top 100 CV scores just prints out, it's just a REST call. So it's printing out a bunch of text here, but you can take a look at this if you'd like to. api.first.org/data v1. All APIs are v1, I feel like, and EPSS. So go ahead and take a look at that when you have your free time. And then you can also take a look at specific vulnerabilities. So anybody have a good vulnerability in mind? CVE number, they have one here. So you can actually find the EPSS scores for specific CVEs, and that would just show up here as a probability score. The higher your probability is, the closer it is to 1.0, the more likely it will be exploited. And it also gives you a ranking of all time. So out of all the CVEs that are ever published, how does it fall in the rating of how exploitable it could be? And this number changes over time a little bit. So another one, it's really cool, guys, cvetrends.com. Some guy, I forget his name actually, Mike something, or Simon Bell. He created this website, and it reads Twitter. It's like threat intel for CVEs. So it takes a look at all the chatter going on about specific CVEs, and he publishes the top 10 or so. And it tells you he tells you how often it's being talked about. And this will help you understand if someone might, a bad actor, is going to try to write exploit code for it. So this gives you more data to give your developers and be like, yeah, this one's trending, this one's probably really important. Let's try to fix this one, guys. All right, back to the slides. So that was first.org EPSS. All right. So if you look at Log4Shell, we got some numbers here, and this is important because when you have something as crazy as Log4Shell and everyone's hair was on fire and no one knew really what was going on, they just knew it was bad. Oh, it's so bad, it's so bad. It turns out later that yes, it's still bad. However, there are some mitigations there. It's not as critical because the libraries aren't active, right? So if you take a look at these numbers, you got a 10.0 rating for the first one that came out for Log4Shell, and it kind of gradually tapers down from there. The EPSS scores in the 99th percentile, so it still ranks in the top 99th percentile here, or top 1%, sorry, top 1%. You can see the probability of that Log4j vulnerability being exploited is 0.9, so very close to 1.0. That means it's very likely to be exploited. And CVE trends, interestingly, would not have told you this because as of today, it no longer shows up in CVE trends because other hot news, other new hotness has taken its place. So you can't rely on any one of these verticals alone. You need to put them all together and tell that story for your developers. What would you do? Here's a couple others. I know you guys don't memorize CVE numbers, neither do I. I'm not weird like that, just weird in other ways. That first one is going to be your Spring4Shell, and the second one's a Visual Studio RCE. That has 6.3, but take a look at the EPSS scores. Both of them are in the top 1 or 2% of all time to be exploited. So even though your CVE has that low rating of 6.3, it's still in that 98th percentile. And it's got a 0.4 probability of it being exploited. And I will say our recommendation is anything with a 0.4 or above, you really should try to fix it. Don't let it go too long, right? 0.4 or higher, the probability of it being exploited pretty high. Because on average, I think these scores are like 0.000. So anytime you see a 0.4 or higher, go ahead and fix that. And interestingly, in the CVE trends, no one's really talking about this stuff because it's old news as of today, not in the top 100. But these are still very vulnerable and exploitable vulnerabilities. And what would you do? So somebody like me, I would see a 6.3, and the old me would have been like, oh, it's just a 6.3, it's totally fine. But the new me, the smarter me, the wiser me, since I'm attending this, one second. Now I'm going to contextualize that data and understand the exploitability of it, and then go fix it. Yes, question?
So, simple question. Under EPSS, does the 0.40 directly equivalent to a 40%
Yes.
likelihood?
Yes.
Okay.
Yeah. I took a Prob and Stat class like 20 years ago. I have no idea how to do that stuff anymore. I didn't know how to do it then either. All right. Any questions on that? EPSS, really cool stuff. Definitely want you guys to check it out because the way we're doing it now, not great.
Does that EPSS score increase over time? Does it help? does that rank? Does it get worse over time?
So it can increase over time, but it most likely will decrease because and the more CVEs that come out, those are going to be a little bit higher in probability to exploit. So it's the overall probability out of all the CVEs being exploited, how probable is that one particular vulnerability going to be exploited. So out of them, so the more you add CVEs into that pile, you know, but if you add a whole bunch of like lower ones, it's going to go higher. So yeah.
It's just looking at it from an age perspective.
Age perspective, yeah.
Bring out all the new shiny, let's exploit this.
See, that's what, if I were a malicious actor, I would do that. I would be like, what are the ones that are not trending? Maybe it's not on the radar for incident responders. Maybe people aren't paying attention to it. I would go straight for those, right? And if you guys haven't patched for your Log4j and Spring4Shell and stuff, like go back, start working on this stuff. It's still important. And ask for a raise while you're at it, right? All right. Here's the last one here that I'm going to tell you about. Licensing risk. Not really a security risk here, but still a risk to your business. Most recently, there's a company called Appian. They're a no-code, low-code kind of thing. Anybody heard of them? Me neither. It's all good. Oh, you, Adam. They recently won $2.068 billion because somebody had used their copyleft license inappropriately. So think about that. That's a great business model, isn't it, guys? Right? Just write some shitty software and be like, you can't use this. I'm kidding. I've never used them. But anyway, so they won all that money, and apparently, appeals and all that, whatever. But interesting, right? So that can affect your organization. If you're sitting here thinking, oh, we're good, they're public licenses, everyone says it's cool to use it, like you got to be careful about what licenses you are using. Here at Contrast, we actually went through every single one of our open source libraries, and we took a look at their licensing. So a good SBOM generator will actually include the licensing information. I implore you to take a look at that. So you're going to read through all the licensing information. You're going to be like, is this one acceptable to our business? Or is it too much risk? And you want to involve your compliance team, your legal team, and they're going to help you understand if that license is going to be acceptable for your business. Some of them, I don't know, I think I wrote these down. Some of those older licenses, not great. I'll tell you, stay away from, I didn't write it down. Yeah, where did I get that information? Oh, okay, there it is. GPL version 3, GPL version 2, and AGPL, those are all bans from specific societies. Do not use those licenses. But go ahead, even things like the MIT and the BSD, the Apache licenses, those are very permissive licenses, they're good, but you still want to talk to your legal counsel to make sure that's acceptable risk for your business. Licensing risk here, 69% of Java applications use some sort of licensing, open source licensing here. 35% in total have one or more specific copyleft license. And copyleft and copyright. Copyleft is just basically, you can use a copyrighted license, just more limited. That's what copyleft is. 99% of organizations have at least one application with a high-risk license. It's pretty interesting data. All right, so we're at the point where we want to start talking about how to actually fix this stuff. So I had mentioned talking to developers, giving more contextual data when you're handing over CVs and libraries to fix. So that's one thing. You want to set policies and have conversations with your development teams, because if you're just handing over things over the wall, you're going to break that relationship with them so fast. But if you guys both understand and set expectations, be like, we're giving you solid data to do something with, they're going to understand that. You're setting a policy for yourself that you're like, I'm always going to follow this process, always going to give you true positives, always going to give you actionable stuff. And the developers are going to understand that. We're always going to fix this within 90 days, whatever. We're going to fix this within 180 days, we promise. And you set that expectation together, you're setting that policy together, then you're going to start making real progress with your development teams in fixing open source. Continuous monitoring, you want to use different tools for this. I won't say which tool you should use, hint, hint, but I work for them. But if you have continuous monitoring, really easy way to see what kind of libraries are active, what kind of routes are being used. A lot easier to map your active libraries to the vulnerabilities, yes? So using all the data available to you, we talked about CVSS, we talked about EPSS, we talked about CVE trends, we talked about different tools like Contrast, and you are going to use that data to make risk-based decisions, not just emotion-based ones, and definitely not just because you heard it on Twitter, right, guys? We don't do that. None of you do that. You don't just go on Twitter and be like, oh my gosh, Kevin Beaumont said. Embed controls in your CI/CD. So again, you can use different tools for this. I won't say which tools, but I know some really good ones. Embed them within your CI/CD. That way, you can automate some of this stuff away. You can say, like, using contextual data, I can tell you which ones are true positives and which ones will save you time, developers. All right, that's actually all I have for you guys. Do you have any questions? No questions. Cool, thanks.